Hello and thank you for joining in for another video on GCSE Maths. This one's paper 3 from June 2017. So I'm going to guide you through all the questions. Some questions I'll do in a couple of different ways if I think it's worthwhile. Otherwise I might just show one solution. Which isn't to say that for any one question there aren't multiple other solutions. So if you've arrived at the correct answer using a different method, probably you're absolutely fine to use that method, but if in doubt, leave a comment in the comment section or ask your teacher in person. So without talking on for any more, let's get straight onto it. Let's have a look together at question number 1. So for question 1, we have what's called a Venn diagram. So this curly fancy E means all the odd numbers which are less than 30. So all the odd numbers less than 30 have to go somewhere in this rectangle. So it could be an idea to just write down all the odd numbers less than 30, just along the top or something. So obviously this is going to be tedious, but it's going to be useful. So 1, 3, 5, 7, 9, 11, 13, all the way up to 30. Obviously not including 30, because 30, as you know, is even. 25, 27, 29. So all the numbers in blue need to go in here somewhere. So set A here means set A, so I'm going to call this one here circle A. So in region A need to go all these numbers, but in region B down here we need to put 5, 15 and 25. So let's think if there are any numbers in both A and B. Well, there's only one number that's in both A and B, and that's 15, which you can see here. So 15 lives in both. So I put 15 in the middle because that's in circle A and in circle B, so that's where they intersect. So because we filled in 15, what we can do here is just scrub out 15 so we don't double count it. Next, what we can probably do is think about the other numbers which are either in A or B. So the other numbers in A are 3, 9, 15, sorry not 15, 21 and 27. We've included 15. So if I scrub out 15, so in any order I need to put 3, 9, 21 and 27 here. So now I can scrub these numbers off. So I've got 3, I've got 9. I'd always suggest to cross them off once you put them in, just so that you don't double count. 21 and 27. And then what we need to do is to do the same for numbers in B. So 5 and 25. So put 5 and 25 in there. So a common mistake now is to think that's all completed, whereas actually it's not, because there are still some numbers which aren't written down in this Venn diagram. So 5 and 25 I can cross off. So these other numbers have not crossed off, need to go into the Venn diagram as well somewhere. So the other numbers are 1, 7, 11. So I'll just put these anywhere on the outside of the circles but inside the rectangle. 1, 7, 11, 13, 17, 19, 23, 29. It doesn't matter how you spread them out. All that matters is these numbers in blue need to go outside of these circles but inside the rectangle. I could have put them all in this corner here, fairly close to each other if I wanted to, so that's absolutely fine. So that's part A done. Part B, it says a number is chosen at random from the universal set which is given by curly E. What's the probability that the number is in the set A union B? So this little U stands for union, and the union of A and B just means the bit of the diagram which includes both circles A, B and the overlap. So if region A joined up with B, AUB is this one here. So it's all of these numbers within the two circles. These are all the elements of A union and B. But we're being asked here for the probability of if any number's picked at random, if the number that's picked at random is in this yellow bit. So the probability of that happening, the probability of picking a number that's in the union of A and B, well, we've got 1, 2, 3, 4, 5, 6, 7 numbers there to choose from out of a grand total of how many numbers there are that are odd in between 1 and 29. If you really want to, you can count them. I'm hoping that you'd probably realise that it should be 15. 30 numbers between 1 and 30, 15 are going to be odd, 15 are going to be even. So the probability of picking something in this region, A union B, is 7/15. Question 2, we have to solve two simultaneous equations. So 3x plus y is minus 4, but as well as that, 3x minus 4y equals 6. So I'm just going to write these equations out slightly bigger and clearer, then we can talk about what to do. Whoops, don't like that pen. Select that differently. There's the pen I wanted. So 3x plus y is minus 4. I'm doing nothing here but just copying the same thing out. 3x minus 4y equals 6. So simultaneous equations which are non-quadratic, what we do first of all is look at the numbers in front of the first letter and in front of the second letter. So the numbers in front of the x's and the y's. All we're wanting, signs not permitting, just looking at the numbers, not the signs, we just need for the numbers of the x's to be the same in both, or the numbers of the y's to be the same in both. Now, if there's no number in front of this y, if there were a number, that would just be plus 1y. But 1 and 4 are not the same. However, 3 and 3 are. So the next thing to do now is to think we're either going to add the equations together or we're going to take them away. Now we've got a matching pair of numbers for the same letters, we're good to go. Only question now is, do we add or subtract the equations? Now, to decide whether to add or subtract, we think of the signs in front of the numbers that are the same. So that 3 is obviously a positive 3. This 3 too is also positive. If the signs are the same, we subtract. If the signs of the numbers which are the same, we subtract the equations. So we're going to do the top equation, take away the bottom one. So, first of all, we're going to take away these x's. So 3x take away 3x will disappear. 3x take away 3x is 0. It cancels. That's exactly what you want to happen. Meanwhile, the y's, I've got 1y minus 4y. If you're subtracting a negative, it makes it a positive. So this is the same as 1 plus 4y, which gives 5y. And then these numbers, I'm starting with minus 4, and I'm taking away another 6. So if you take away 4, and then also take away another 6, you've taken away 10. So 5y equals minus 10. Now we can divide by 5, so that y will be minus 10 divided by 5, which is minus 2. So all we needed to do there was to divide both bits by 5. Now we know that y is 2, we can pop that value back in to one of the initial equations. And it doesn't matter which one you want to go for, your choice entirely. The only thing I'd say is pick the easier looking equation if you can. So if y is minus 2, my suggestion would be to pop it into this one at the top, because that's just 1y, and 1y is easier to deal with than minus 4y's. So the equation at the top, which I'm going to just ring in blue, substituting in minus 2 in place of y, this one becomes 3x plus y, so plus minus 2. Adding minus 2 is just the same as minus 2. That equals minus 4. So all I've done here is I've erased y, the letter, and put in the value of y in its place. That's y, and minus 2 is y. So I've just switched the letter for the number. Now we just need to solve it. We need x on its own. That minus 2 needs to disappear, so we do the opposite to it. To make minus 2 disappear, we add 2, but if we add 2 to this side, we do the same over here. So that will give us 3x is minus 4 plus 2 in the positive direction, so we're going to go less negative. Minus 4 add 2 takes us to minus 2. Finally, to get 1x, instead of 3x's, we can divide by 3, and therefore divide by 3 on this side. So therefore, our final step, x is going to be minus 2 divided by 3, which is best left as an exact fraction, minus 2 over 3. So the full solution is therefore that y is minus 2, and also x is minus 2/3. And then we're done. Question 3, we have a frequency table, and it's showing information about the dress sizes of 25 women. For part A, we have to find the median dress size. Well, median just means the middle one. So if we imagined these 25 women stood in order of terms of what their dress sizes were, as ridiculous as that idea is, and as out of order as it may be, just imagine it mathematically is what I'm saying, then if you had 25 women in order, then there'd be 12 women at one end, 12 women at the other end with slightly larger dress sizes, and there'd be one woman in the middle who would be the median. So the median is going to be the 13th. Apologise about my drawing, no sexisms intended. My art is absolutely shocking. That's the middle woman. So 12 one side, 12 the other for medians of 13. So we need to use this table to find whereabouts in which category the 13th woman would be. So if we do like a running total here, which I'm going to call cumulative frequency, CF, then the first two women are here. So obviously that's nowhere near the 13th woman. Then for dress size 10 and dress size 8 is the first 2 plus 9 women, which is 11. So the first 11 women are either going to be a dress size 8 or 10. So we're not at the 13th one yet. So the 10th and 11th woman would be dress size 10. Then the 12th woman becomes dress size 12, and the 13th. In fact, the next 8 people after the 11th would have a dress size of 12. So the 12th up to the 19th woman would be dress size 12. Because the 13th is in between the 12th person and the 19th, we can therefore deduce that the median dress size must be 12, because the 13th woman would fall into this category. So median dress size is 12. The next one for part B, we've got some thinking to do. So we've got 3 of the 25 women have a shoe size of 7. Okay. Zoe reckons that if you chose at random one of these 25 women, the probability that she has either a shoe size of 7 or a dress size of 14 is 9 out of 25, because 3 25ths plus 6 25ths equals 9 25ths. So, is Zoe correct? You must give a reason for your answer. Well, she's not correct, but we need to be careful as to explain why. The maths on the surface is fine. 3 out of 25 as a fraction, that looks reasonable. And as she says about the 25 women having a dress size of 14, she thinks that 6 out of 25 women have a dress size of 14. If you check the table, you can see that she's right. 6 women have a dress size of 14. So this maths is absolutely fine. 3 out of 25 have a shoe size of 7, and 6 out of 25 of them do have a dress size of 14. But she's done wrong by adding together these fractions. For example, what if somebody had a dress size of 14 and a shoe size of 7? So actually they could both happen together at the same time. So it's not a case of people can be one or the other. People might actually have a shoe size of 7 and the same dress size. So that's the reason why she's incorrect. So is she correct? We need to say no, because for example a woman might have shoe size 7 and also a dress size of 14. For question 4, we're talking about Daniel baking 420 cakes. He bakes only vanilla, banana, lemon and chocolate. 2/7 of the cakes are vanilla cakes, 35% of the cakes are banana cakes. Then here we're talking about the ratio of the number of lemon to the number of chocolates is 4 to 5. So that's worth highlighting. So lemon to chocolate, 4 to 5. Work out the number of lemon cakes Daniel bakes. So what we need to do first of all is to think about this ratio and see if we can work out the total number of lemon, chocolate, or ideally both. And for ratios, often the best thing to do is to put them into a table of values, something a bit like this. So 4 lemon, 5 chocolate, 9 lots of cakes in total, just considering the lemon and chocolate, of course. So we're told here that he's baked 420 cakes in total. And we're also told that 2/7 of these cakes are vanilla cakes. So the vanilla ones will have 2/7 of, so multiply 420, that will tell us the total number of vanilla. So let's work this out now on the calculator. So 2/7 multiplied by 420. So we get the fraction button, and just type in 2/7 multiplied by 420, That gives us 120. So 120 of these cakes are vanilla. 35% of the cakes are the banana cakes. So in the same way as we worked out a fraction of 420, we can work out the 35% of 420 to find the number which are banana cakes. So 35% of 420, so 35 shift percentage button of 420, 147. So I've got 147 banana cakes. Now from this, we can work out how many cakes must be lemon and chocolate. If they're not vanilla or banana, the other cakes that are left must be lemon and chocolate, because they're the only 4 flavours that he's baking. Therefore, the total number of lemon and chocolate cakes must be 420 minus the 120 and 147. So therefore, just write that down. Total for a lemon and chocolate is going to be the total 420 minus the 120 minus the 147. Whatever's left has to be the lemon or chocolate. So if we just do this on the calculator and see what we get. So 420, take 120, take away 147. That gives us 153. So it must be 153 lemon and chocolate cakes all together. So in actual fact, the total number of these lemon and chocolate cakes isn't 9. The actual total number of cakes is 153. So these 9 batches of cakes, we can think of this as. We can think of it as like maybe 4 batches of lemon and 5 batches of chocolate. 9 batches of cakes need to represent 153. So what would we need to scale up by, to multiply by, to go from 9 to 153? Well, to find that value, to find how many times bigger one number is than the other, we do the big number divided by the small number. So if we just now do 150 divided by 9, we can see that we need to multiply by 17. Therefore, to keep the proportion the same, we need to multiply the other ratio parts by 17 as well. So the total number of chocolate will be 5 times 17, but ultimately this question is concerned with the total number of lemon cakes only, so that's going to be our answer. So we're just focusing on the lemon, so we just focus on the 4 times by 17. If we do that on a calculator, we should see that the answer is 68. So therefore, there's a total of 68 lemon cakes that Dan has baked. We can now move on and think about question 5. Question 5, we've got some regular polygons. So we've got AB, BC and CD, which are 3 sides of a regular polygon, which has just been called P. So this shape here, this polygon P, we need to imagine does exist. It's not just these 3 sides. So it would be up here, then to the right, and then to the right as well there. So that's what we need to imagine it as. It needs to be a regular hexagon. So do not think there's like a hole in these squares. There's actually a real hexagon here. So you need to picture it like this. And in fact, draw it on if you find it useful. So let's just pick apart this question. So the first thing to consider, this is a 12-sided polygon, so you need to imagine more sides going around. So I've added on another couple here. We can also try to work out the exterior angle. Now the exterior angle is the imaginary turn between this bit here and going back to the new side. So I'm going to draw on an exterior angle. So if I just extend these lines here and that one there, then the exterior angle is just this here on the outside of the shape, as in external exterior. So the exterior is big capital E, and the interior angle is on the other side of this straight line. I'm going to label this I. So I and E, the interior and exterior, do relate to each other. So first of all, we can say that the interior and exterior add up to 180, because angles on a straight line add up to 180. But like I've revealed here, the exterior angle for any regular polygon is always going to be 360 divided by the number of sides. So because this is a regular 12-sided polygon, then we can do 360 divided by 12 to work out the exterior angle of the 12-sided polygon. So 360 divided by the 12, that's going to give us 30. So the exterior angle is 30 degrees. We can then work out the interior angle, and the interior angle here, because it's a regular polygon, all the interior angles will be the same as well. So this angle here where B and C are, they'll also be the same green angle I. So this one and that one will be I's as well. So like I said earlier, the interior plus exterior will always add up to 180 degrees because they always make a straight line. So I'm just going to put this over here. That's well worth knowing if you didn't already. Hopefully you do. But interior plus exterior will always add up to 180 degrees for any regular polygon. So because of that angle fact, if the exterior is 30, this interior angle will be 180 minus 30, which is 150. So therefore, that one's 150, but also, like I mentioned earlier, this one's 150, and the other one would be 150 as well. Now ultimately, we're trying to focus in on polygon P, not this 12-sided one. So we know this interior on the other side of P. We can also as well, or we should well know what the interior angle of a square is. It's quite obviously a right angle. So that's going to be 90 degrees. And I is 150, so I can label this on as being 150. We can then work out, because we know that's 150 and that's 90, we could work out the interior angle of polygon P. So I'm going to call this interior subscript P, which means interior angle of polygon P. Angles around a point, as in here, will always add up to 360 degrees. It's like turning around a circle, you have to do a full 360. So using that angle fact, we can say that the interior angle of polygon P, IP, plus the right angle of the square, which is obviously 90 degrees, plus the interior angle of a 12-sided polygon, which is 150, those three here are angles all the way around a point, so they need to add up to 360. So just again to recap where these angles have come from, 90 degrees because of the square, 150 degrees because of the internal angle of the 12-sided shape. So we can now simplify this. So 190 plus 150 is 240. So IP plus 240 equals 360. Therefore, we can take away 240 from both sides to work out what the interior angle of this polygon is. The interior angle of a polygon must be 360 take 240, which is 120 degrees. So therefore, we can work out what the interior angle of polygon P is. So the exterior angle of polygon P. So like I said here, the interior plus exterior always adds up to 180. So we can say that the exterior angle of polygon P is going to be 180 take away the interior angle, which is 60 degrees. And the final step, from this equation here, we could rearrange this. This also tells us the number of sides of any regular polygon. So by rearranging this equation, the number of sides is 360 degrees divided by the exterior angle. So we can therefore work out number of sides of P is 360 divided by its exterior angle, which is 60 degrees. 360 divided by 60 equals 6. If it's a shape with 6 sides, by definition, it is a hexagon. A hexagon has 6 sides. So therefore, polygon P is a hexagon, because we've clearly shown and demonstrated with careful reasoning that it must have 6 sides if the shapes are in this configuration. Question 6, we've got an awful lot of information to tackle. The second word is density though, so we know it's going to relate to density, mass and volume. So this is a formula you need to know. So the first thing we need to consider is that we're needing to work out the density overall of a drink, which is a mixture of different things. This drink is going to include apple juice, fruit syrup and carbonated water. So there's 3 different components to be considering here. So like I said, it's going to relate to density, and density is a formula. The density of a substance is the mass of it divided by volume. D equals m over v. And whatever you're trying to work out, you can just cover up with your hand or thumb, which I've got here, and I'll show you how to do that in just a moment. But like I say, there's 3 different things to be considering. So the first thing is we're talking about apple juice. We're told here the density of the apple juice. We're also told the volume of the apple juice is 25 cubic centimetres. So one thing is apple juice. The next thing that's mentioned is the fruit syrup. We're told its density. We're also told the volume of fruit syrup. And the third and final ingredient is carbonated water. We're told the density of that. We're also told the volume of it. So because we're told the density and volume of each of these 3 ingredients, we can simply cover up m, because we want to find out the mass of these, and just multiply the density of each one multiplied by the volume of each thing. So let's do that. Let's work out the mass of the apple, the mass of fruit syrup, and the mass of carbonated water in this drink. So the first thing is going to be the apple. So for the apple, well, apple juice, but you know what I mean by apple, hopefully. The mass of it will be the density of it times by the volume. The density is 1.05 grams per cubic centimetre, and the volume, highlighted in green as well, is 25. So the mass of apple juice is 1.05 multiplied by 25. Let's see what that gives us. 1.05 times 25. That gives us a mass of 26.25 grams. We then need to do the same process for the next ingredient, which is the fruit syrup. So looking at this fruit syrup, we just do the same idea for that one. So for the fruit syrup, the mass of it will be the density of it multiplied by the volume of it. So the density of fruit syrup we're told is 1.4. We're also told the volume of it is 15. So 1.4 multiplied by 15, that'll tell us the mass of fruit syrup. And again, use your calculator for this, because you may as well. 1.4 multiplied by 15 gives us 21 grams of fruit syrup. Finally, do the same for the water, or carbonated water if you want to be technical about it. I'm just going to call it water because I'm being a bit lazy. The mass of water is density times by the volume of water. The density of this water is 0.99 grams. Now the density of normal water, if you like, is exactly 1 gram per cubic centimetre. So carbonated water means it's fizzed. So the gas is less dense than the water. So the tiny bit of gas which is in it is less dense. That lowers the density of it slightly from exactly 1 to 0.99. Interesting little factoid there for you, or maybe it's not interesting at all. You make that conclusion. And the volume of the water is 280. So we do 0.99 multiplied by 280. So let's work this out now on the calculator once again. 0.99 multiplied 280 gives us 277.2 grams. So now we've got all we need to work out the density of this drink. So the density of the drink is what we're trying to find now. So now I can cover up density, which will be the mass divided by the volume. So the density of the drink is made up of the apple, the fruit, and the water. So it's going to be the total mass divided by the total volume. So the total mass of this drink is going to be the mass of apple, which is 26.25, plus the mass of fruit syrup, which we worked out as 21, plus the mass of water, which is 277.2 grams, So just to recap, that's what we worked out the mass of apple was. This next one here was the mass of the fruit juice, and finally the mass of the apple juice. We're going to divide by the total volume. The total volume will be the volume of the apple juice, which was 25 cm cubed. The volume of the fruit syrup was 15, and the volume of water was 280. So that's a calculation we need to do now. So 280 is for water, the 25 cm cubed was the apple juice, and finally the 15 cm cubed was the volume of the fruit syrup. So we just type this into the calculator very carefully indeed, of course, and what will come out is our final overall density of our drink. So 26.25 plus 21 plus 277.2, all of that divided by 25 plus 15 plus 280. Press equals, S arrow D to get a decimal answer. And now we can see we want it to 2 decimal places, so we're going to round it off to just the 0 and the 1. That 1 will not round up to a 2 because next to it is only a 3, so don't round up. So the first 2 decimal places we're going to keep are the 0 and the 1, which makes our final answer 1.01 grams per cm cubed. And that is our final answer, which means we can now move on and think about question 7. Question 7, we have a right-angled triangle. Hip, hip, hooray. Right-angled triangles we like because they're the easier types of trigonometry. Calculate the length of AB, give your answer correct to 3 significant figures. So if you see a right-angled triangle, you should be thinking in terms of Pythagoras or trigonometry. Here we know a side and another angle, and we want to find a side. This is going to be trigonometry. So for trigonometry, we need to be thinking of these 3 things, SO, CA, TOA. And again, I'll include a little tiny hand to cover up what we want to work out. I'll come to that in a moment. So, the first thing I'd say would be to label the sides of the triangle. So the opposite side of a right-angled triangle is the side which is opposite to the angle in question. 23 degrees is the angle we're given, so that's the opposite side. The longest side is called the hypotenuse, so I'm going to label this C to A as H for hypotenuse. The longest side is also always opposite to the right angle. The other side, the odd one out I think of it as, is the adjacent, which I'm going to label as A. Now, which side do we know? Well, we know the hypotenuse because we're told that's 15. So we know the hypotenuse, so I'm going to highlight this in the SO, CA, TOA triangles. I'm also going to highlight the side I want to know. I want to know the opposite side, so I'm going to highlight this wherever I see it. Always highlight the side you know and the side you want to know if you're trying to find a side. Next, we think about if it's going to be the SO, CA, or TOA triangle we're going to be using. Always pick the triangle that has the most highlighted stuff in it. So for this one, the SO triangle has 2 sections highlighted, the others only have 1, so for that reason, we're going to zoom in and use the SO triangle. So I'm going to cover up everything else because we're just going to use the SO triangle, because that's going to be most useful to us. So now we cover up the side we're trying to find. I want to work out the opposite side, so I cover this up here, like so. The opposite side will be S times by H, because S and H next to each other just means one multiplied by the other. S stands for sine of the angle we're talking about, so S stands for sine of 23, put this in brackets, and H is obviously the hypotenuse, which we know is 15. And this calculation will tell us nicely what the opposite side is. So we just type this in carefully into our calculator. So sin 23, close the bracket, multiply by 15, press equals, 5.86. Now we want our answer to 3 significant figures. So 5, 8, 6 are the digits we keep. That 6 doesn't change because next to it's only a 0. So 5.86 is our final answer. 5.86 centimeters. And there you have it. Question 8 I do think is a very hard question 8 by the standards of what question 8 normally is. Normally question 8s aren't the most fiendish of questions. This is quite tricky, I think, so let's just talk it through. You've got a square with sides of length x centimetres is inside a circle. So you've got like a square with its corners just scraping the inside of a circle. So I'd suggest to just sketch this out first of all. So the square has sides x and it's inside a circle. So first of all, let's get a circle up and ready. Let's put a square inside it, but like I've said, each corner, each vertex of a square is on the edge, on the circumference of a circle. So we need 4 points on the circumference on this blue curve, like so. And because it's a square, we're going to draw on each dot to dot in a green line because I've highlighted the square underlined in green. So this is the square, and each green side of a square is x centimetres long. Importantly, because it's a circle, and we need to work out the radius of the circle ultimately, because we know the area, what we can do here is add on the radius, because it might well be worth calculating this radius now. So we're told the area of a circle, which obviously is a good thing. So for any circle, the area, as we should know, is pi r squared. Now we're told the area is 49, so 49 equals pi r squared, and that's because we're told the area is 49. Now we want to work out the radius, because the radius will help us in the next part of the question. So what we can do here is we could divide both sides by pi to get the radius on its own. If I divide that side by pi, I need to divide by pi over here as well. So that'll give us that the radius squared is going to be 49 divided by pi. And the final step would be to square root both sides, because to go from the radius squared down to just what the radius is, I need to just square root. And if I square root one side, I square root the other. So therefore, from that, the radius is going to be the square root of all of 49 over pi. So 49 over pi, all of that square rooted. Press shift, this button here to get pi, press equals, and I get this long awkward number. Now this long awkward number is not our final answer. So what I'm going to do here, I'm just going to write down plenty of decimal places so I don't incur any rounding error. So I've got 3.949 to start with. And then I've got 327, so I'll write down another 327. Okay, so that's what the radius is, and we're going to use that now on the next stage of answering this question. The next thing we can do, using this value of r, is we can section out this square into 4 exact equal triangles, 4 congruent triangles, centered on the center of this circle itself. So if I just divide this square into 4 triangles and label on the radius, we'll get something like this. So if I just focus on just one of the triangles, doesn't matter which one I pick because they're all identical, then I know this side's 3.949327, it's for radius, as is this side, and then the side of the square I'm trying to work out is x, so I've got a right angled triangle here, and if you get a right angled triangle, you should know, therefore, that we can use either trigonometry or Pythagoras to work out what the longest side is. And so I'm going to show you 2 different ways now of how we could work out x. So the first one I'm going to show you is trigonometry. So this is the side we want to find, and we also know, because we've split this square into 4 equal triangles, that we've also halved each of these corners of the square. Now a full corner of a square, you know, is a right angle. So because I've halved these corners, each angle here is going to be 45 degrees. So on our triangle put here in blue, I know that one's 45 degrees as well. So let's say I keep this side here, which is the adjacent, by the way. If I label this the adjacent, that side here is the opposite. I'm trying to find side x, which is our hypotenuse. Then using trigonometry, you could have just used Pythagoras, I'll show you that in a second. I want to work out the hypotenuse. That's what I'm interested in. So I'm going to highlight this on the SOHCAHTOA triangles. And as well as that, I do actually know the adjacent side, which is 3.949327, and a few bits and more. So I know the adjacent, so I'm going to highlight the adjacent on these soccer turf triangles as well. Next, I pick whichever triangle is the most coloured in, the most useful. So K has two things highlighted, the others only have one, so for that reason I'm going to go for the K triangle. So the others we can say goodbye to. I'm going to be using K, so it's going to be involving cos. Now I want to work out the hypotenuse, so I cover up H for hypotenuse, and that's going to tell me what to do. So I've only got A on top and C on the bottom, therefore H equals A over C. And H is obviously our X. So in fact what I could do, I could just call this our X. The adjacent side is 3.949327, and C stands for cos of the angle in question, so it's going to be cos of this 45-degree angle. So I'm going to type this into the calculator carefully. So what we're going to get is 3.949327 divided by cosine of 45, and we get here to three significant figures for question once, 5, 5, 8. Or maybe that 8 will round up so it becomes 5.59. Well, that 8 will round up because next to it is a 5. If it's 5 or higher, we round up, remember. So instead of 5.58, our final answer is 5.59. And that's using trigonometry. If you're thinking, why did he do that? He didn't need to. That's true. I'm going to show you another way, which might be simpler, but I just thought I'd show you both ways, just in case you were confused in the exam, which way to use. You could use either way. Instead of trig, we could have just used Pythagoras straight away. So a second option, alternative, we actually knew the hypotenuse could be worked out because we knew the adjacent and we knew this opposite side too. The opposite and the adjacent are both radiuses, so this opposite side was 3.949327 as well. So hypotenuse squared equals that one squared plus that one squared. So the hypotenuse is a square root of that one squared plus that one squared according to Pythagoras' theorem. So using Pythagoras, I could have just done 3.949327 squared for the opposite plus that same value again for the adjacent, because the shorter sides are both the same, they're both this radius. So one side squared plus the other side squared, all square rooted to find the hypotenuse. Again, you would find, using Pythagoras instead, it is 5.59, which the final answer therefore is 5.59 centimetres. Whether you use Pythagoras or trig, 5.59 is the final answer to that one. Question 9, we have some box plots to have a look at. So we've got information here about the distribution of the amounts of money spent by some male students on their holidays. Part A, we're asked to work out the interquartile range for the amounts of money spent by these male students. We need to know that a box plot includes 5 key pieces of information. So the interquartile range is tied up in these 5 pieces of information. The 5 pieces relate to these 5 vertical lines here. The first vertical line, second, third, fourth, and fifth. So these vertical lines, the first one is always the lowest value. The second vertical line, the first vertical line in this box, is the lower quartile. The line going down, splitting the box, is the second quartile, better known as the median. 2/4 is halfway, so that's the median. This one here is the upper quartile, and the final vertical line is the largest or highest value. The interquartile range is the length in between Q1 and Q3. In other words, it's Q3 minus Q1. The interquartile range is the upper, take away the lower. So the upper, Q3, we can see that's 300, that's therefore 320, that's going to be 330, and Q1 is going to be, that's 200, so 180, 160, that's 150. So it's going to be 330 subtract 150, and that gives us a value of £180. So that's our interquartile range. For part B, we need to do our own box plot. So we're going to do a box plot now of the amounts of money spent by some female students. So lowest, lower quartile, median, upper quartile, and largest. We've got our 5 pieces of information here to put onto the box plot straight away. So first of all, let's just label this female students. The smallest value is 60, so we do a vertical line at 60. So first of all, that's our first line. Lower quartile at 180, so a vertical line at 180. Medians at 300, so a vertical line at 300. Upper quartiles at 350, so you can guess what to do next. Finally, the largest is 650, so we do a nice vertical line at 650, and that's the hard work done. So fill in these with clear vertical lines, like so. Then between the 3 middle vertical lines, we put a horizontal line across at the top and bottom to form the box, and from the second vertical line to the first, a horizontal line connecting it, and the same from the 4th to the 5th. So it should look like this once done, and that's the box plot for the female students. Part C is an interpretation question. Chris says, the box plots show that the female students spent more money than the male students. Is he correct? Well, it's a general statement about who spent more, who spent less. So if you want to come to like a general sort of statement about a distribution, you want him to be talking about the average. So if the average can mean the mean, in terms of box plots, a measure of average, we go for comparing the medians. So which distribution, the males or females, has the highest median? So we can see here that the female student's median was 300, whereas for the males, the median was only 250. So generally speaking, he is correct, because the average female student spent £300, whereas the average male student, you could say, spent £250. So it's not to say that every female student spent more than every male student, but in general, yes, Chris is correct. So we need to say something like this to answer the question, is he correct? Well, yes, he is correct, generally speaking. You don't need to put in general, but you can do if you want to. Yes, he is correct, but the main thing to say is the median for females is higher than the median for the males. If you wanted to, you could say the median for the males is lower than the median for the females, but it's an equivalent statement to make. So the answer is yes, the reason the median for the females is higher than the median for the males. And that's all we need to say for question 9. Question 10. Niobe's investing £6,000 for 5 years. The investment gets compound interest of X% per annum. Per annum just means per year. At the end of the 5 years, the investment is worth £8,029.35. We need to work out the value of X. So this is a compound interest question, obviously, but it's a reverse one. We're not told what the percentage interest is. That's what we need to work out after being told the value at the final 5 years. My suggestion here is to try and link it back to what we know already about compound interest questions. So what I'd like you to remember here is that for compound interest, generally speaking, the final amount always equals the start amount. This is for compound interest, multiplied by the decimal multiplier, I call it. So multiplied by some multiplier. And that multiplier is always multiplied by the power of the number of years. Or number of time periods. It might be the number of months in a different question. So what we've got here, we're told what the final amount is. The final amount, we're told, is £8,029.35. So that £8,029.35 must be the start amount. We're told what it starts at as well. She puts £6,000 in to begin with. So the start amount is 6,000. Now we don't know what the percentage interest she's getting is yet. So therefore we don't know what this value is being multiplied by. So I'm just going to put the multipliers equal to some question mark. But the number of time periods this has been invested for, we are told. We're told that it's been invested for a total of 5 years. So the total number of years, the total power that this multiplier is acting for is 5 years. So we need to raise this multiplier to the power of 5. This is now an equation to solve to work out what this multiplier is. So what we can do is try and get this question mark on its own. We can rearrange the equation. What we could do here is divide both sides by 6,000 to get rid of this £6,000 here. So if we divide both sides of this by £6,000, or 6,000, what we'll get is what this question mark is to the power 5. Because that's for 5 years. So £8,029.35 divided by 6,000. We get this thing here, 1.338225. Write down all the numbers because this isn't your final answer yet. So you've got 1.338225. Almost missed out a 3 there, 338225. Now, this question mark's been raised to the 5th power. If it was squared, we'd do the square root to find it. If this was being cubed, we'd do the cube root of this. The opposite of doing something to the power 5 is to take the 5th root. So I'll show you how to do this on a calculator. But this multiplier is going to be the 5th root, so I can look at a square root symbol with a little 5 here of this 1.338225 number. So how we process this on the calculator is we press Shift on this Casio. We then look for this button here where it's got a box, tick and another box. That's where we can put in whatever root we're wanting to find. We're trying to inverse the power 5, so that's the 5th root of our answer. Press equals, and we get 1.05, then 1, 2, 3, 4, 5 nines after it. So 1.05, 1, 2, 3, 4, 5, 0.8. Now, because we're talking in terms of percentages, it's probably worthwhile multiplying this by 100 to convert it into a percentage. So this times by 100, to change from a decimal to percentage, is 105.99999%. Now remember, before anything happens to an amount, you always start with 100%. So 105.99999 is, as near as damn it, 106%. So this multiplier must be an original 100%, because remember we always start with 100% of a value, plus an extra 6% on top. The interest is just simply the added extra percentage on top of the 100% you begin with. So to go from 100 up to 106%, we must have added on 6% of interest. So therefore the value of x, which is the interest, x must be 6%. So therefore x equals, well, it's given a percentage anyway, so x% is 6%, so we can just say x equals 6. If you wanted to say x equaled 5.9999908, that's fine as well. I've just rounded it to near as damn it 6. So x equals 6. This person gets 6% compound interest for those 5 years. Question 11. Jeff is doing some gardening. He's choosing a shrub and a rose tree for his garden. At the garden centre, there are 17 different types of shrubs and also some rose trees as well. Jeff reckons there's 205 different ways to choose one shrub and one rose tree. So he's got 17 different types of shrubs and some rose trees. Let's imagine picking them on a menu. So there's rose tree and shrub combinations to be made. He reckons there's 215 combinations in total. We could picture it like this in some form of table. So we've got 17 shrubs to choose from here, and each of those could be matched to some rose trees. We're not told how many rose trees there are though. So imagine this is the first rose tree, that's the second, that's the third, all the way up to the nth rose tree, where n is some number, we're not sure what it is yet. But all of these boxes here, they relate to the total number of combinations. So all of these boxes here in blue would have to total exactly 215 if Jeff were to be correct. So what calculation could we do to work out the total number of these light blue boxes? Well, it's essentially the area of a rectangle. We've got 17 rows multiplied that by n columns. So 17 multiplied by n needs to equal 215, because 17 times by n has to equal the total number of combinations, which is 215. So 17n equals 215. We can therefore divide both sides by 17 to work out the required value of n. So therefore n needs to be 215 divided by 17. Let's see what this is. So 215 divided by 17. This gives us a value of approximately, look, it's recurring, 12.6. And so for Jeff to be correct, there'd have to be 12.6 rose trees. Now just think about that. Does that make sense? Can you have 0.6 of a rose tree? Well, the number of rose trees is a discrete variable. There's either one rose tree, or there's two, or there's three. The number of rose trees has to be a whole number. But we've just established that the required number of rose trees is not a whole number. So what we've got here is a nonsense. This can't be the case. So in terms of Jeff being correct, he can't be. So in terms of showing how you get your answer, we need to clearly show that the required number of rose trees for him to be correct would be 12.6. And then we conclude by saying Jeff isn't correct with reference to the fact this needs to be a whole number, but is not. So the wording for the full marks needs to be something like this. So is Jeff correct? Ultimately saying no, very clearly he's not, and words to this effect are put in blue here. So no, because the required number of rose trees is 12.6, which is not possible because it's not a whole number. So that's why Jeff has to definitely be incorrect. Question 12. A, B, C, D lie in order on a straight line. So we've got this information here. I'd honestly suggest just to sketch out this straight line. So a straight line I'm going to do in black. So here's my straight line. So these points are in order. So we're told first of all that AB to BD as a ratio is 1.5. So I can now add on the points A, B and D like this. So AB is 1 part, BD is 5 parts. And that part plus that part gives the full straight line. From A to B, and then from B all the way to D, that's all the straight line, because the straight line is all the way from A to D. The next part of the ratio says that the ratio of A to C to D is 7 to 11. So we can add this on here. We can do a portion of a line AC and then another portion CD, those two added together in the ratio 7 to 11, and we'll also make the full line, because you go from A all the way to C, then from C to D. We need to now combine this ratio to work out the overall ratio of AB to BC to CD. So we can put this ratio into a table. Almost always I'd suggest for ratios to do a table of values. Something like this would be absolutely fine. So let's just fill in what we've done so far. So we know that from AB to BD was 1 to 5. That was a total of 6 parts. We also know that from AC to CD was 7 to 11. So that's 7 parts, and the 11 lots for CD. 7 plus 11, that gives a total of 18. Now, AB to BD, that represents the full line, as does AC to CD. So these ratios are both representing the same total, but yet the totals don't add up. They don't match up right. So what we need to do here is to get these total numbers to match, because the totals relate to the same total length of this line. 6 isn't the same as 18. Could we get it to be 18 by multiplying by some value? Well, yes, we could. We could multiply this whole line by 3. then the totals will match up correctly. 6 times 3 is 18, 5 times 3 is 15, this 1 times by 3 is obviously 3. So now, because they all match up, we can combine these on the same row. So AB to BC to CD. AB now, we've got 3 lots. BC, now we have from B to C, we can work out here as such. So we know that from A to B is 3 pieces. From C to D is 11 pieces. So we can have this on as well. That's 11. And the total number of parts we've made to be 18. So if A to B is 3 pieces and C to D is 11, 3 plus 11 is 14. The total needs to be 18, so from B to C must be an extra 4 pieces, because 3 plus 4 plus 11 gives us the required 18. So BC must be 4. And then finally, from C to D, we know is 11. As a double check, that adds up to 18 as well. From A to B, 3 plus 4 plus 11 also gets us the same 18 parts. So it does make sense, it does add up, and that's our final ratio, 3 to 4 to 11. Question 13, we have 3 different lines drawn on a coordinate grid, and these lines represent inequalities. So these 3 lines, apart from the lines that make the axes, we need to write down the 3 inequalities that define the shaded region, which is between all of these 3 lines. So this region here is made up as being between these 3 lines, which we need to work out the equations of. So let's just take it one line at a time. So there's a line here at the bottom, which I'm just going to go through in red. Now this line in red crosses the y-axis at -2, and it's a perfectly horizontal line. A line which goes horizontally through the y-axis always has the equation y equals. So this graph here in red is the graph of y equals where it crosses the y-axis. So that's y equals -2. So that's that line there. However, because this line actually represents an inequality, we need to adapt this line here. So it's not actually y equals. Because it's an inequality, we need an inequality symbol instead of the equals. First of all, let's have a look where this region is, which has been shaded in. Well, this region is above the line y equals -2. So we want nothing below where y is -2. So we don't want y to be less than -2, because that's not where the region is. Therefore, we need y to be greater than -2. So this red line is actually that y is greater than -2. However, you should know now that inequalities come in different flavours. You could have one like this where y is strictly greater than, and also it could be that y is greater than or equal to. So because this line is filled in completely rather than being dotted, a filled in line takes more ink than a dotted line. So a filled in line therefore has this symbol here or this symbol like so. It has a line underneath. Having a line underneath the symbol to mean or equal to takes more ink, just as a full line takes more ink as well, whereas a dotted line will be strictly greater than or strictly less than. So because this is a filled in line, a full line, we need to put the line underneath the inequality like this. So this red line here is that y is greater than or equal to -2. Let's have a look at the other 2 lines now. So we've got a line going through the origin, which I'm going to shade in now in blue, this one here. So for this one we can work out the equation of this blue line. Well, it goes through the origin, so we can say it's y equals so many x's plus c, where c is the y-axis intercept, c will be 0 because it goes through the origin. Let's have a look at some points. When x is 2, y is 2. When x is 4, y is 4. When x is minus 2, y is minus 2. Whatever x is, y is. This is y equals x. It's a straight line, y equals x. However, because we're talking about inequalities, of course, just like the red line before it, we need to know to replace the equals with an inequality symbol. Again, it was a filled-in line, so it's going to have one of these symbols like this. Now, which side of the blue line is our region in? Well, it's not on the lower side of this. It's not where y is less than x. It's not down there, so I'm going to cross off all those points. Y is on the high side of this blue line. Y is on the upside over there. So therefore, we want y to be more than or equal to x. So the second inequality we're wanting is that y is more than or equal to x. The final line we've got to fill in is this this green one I'm going to put on here. This one we need to work out the equation of. Now this is a bit harder because this isn't quite as obvious. So what we can do here for this green line is to perhaps work out the gradient. So the gradient of the blue line, keeps calling it blue, I mean the green line, let's just take any 2 points and work out the difference between those 2 points. So if I take this point here, that's 6 and 4, and I could also take this point here, which is 2 along and 2 up. Then for this green line, the gradient is the change in y between these 2 points. So it's gone up from 2 to 4. It's gone up by 2, divided by the change in x. So x has gone from 2 up to 6. X has increased by 4. So the gradient of this one is therefore a half. It crosses the y-axis at 1. So c is 1. So therefore, the green line is y equals a half of an x plus 1. However, for this one, we're wanting the shaded region to be below the green line. We don't want it to be above. We want y to be underneath this green line. So actually what we're wanting here is y to be less than or equal to a half x plus 1. So the final inequality is y is less than or equal to half of an x added to 1. That's question 13 done. That was quite tricky, I think, but that's what we need to do to secure the marks. Question 14a, we need to simplify an algebraic fraction. If we've got something awkward algebraically, like this in a fraction, where there's a quadratic on the top and a quadratic on the bottom, and it's a non-calculator paper, or even on a calculator paper, always check if the top or the bottom, or both, will factorise. And almost all the time, both top and bottom will. So first of all, let's look at x squared minus 16. Will that factorise? Well, yes it will. This here is difference of 2 squares. And so the square root of x squared is x. The square root of 16 is 4. So in one bracket we have x plus 4. In the second bracket we have x minus 4. That's how that one's factorised. The bottom bit here will actually factorise as well. This is slightly longer winded though, so I'm just going to do this on the other side, then we can return to it and pop in the factorised version in green like so. So I'm just going to return to this bit here. First of all, I'm going to talk you through how to factorise 2x squared minus 5x minus 12. So each teacher has a different way of teaching it, of course. First of all, what I'd say here, double check if the 2, 5 or 12 have any common factors. Can I factorise out any numbers first of all? Well, I can't. I can divide the 2 by 2, but 5's odd, so I can't do anything. That's as simple as we can go. So then we can do the next step. What we can do now is shift that 2 to the end and multiply it by the minus 12. Have that 2 disappear for a moment. It'll come back in a while. But think of this now as just 1x squared minus 5x. then 12 times 2 is 24, and then factorise this one in the normal way. That 2's disappeared, we'll bring it back in a moment. So in the normal way, to factorise this, we'd find two numbers that multiply together to give us minus 24, but when you add them up, we get negative 5. So with a bit of thinking, you should find that those numbers are positive 3 and minus 8. Because 3 take away 8 is minus 5, and 3 multiplied by minus 8 gives minus 24. That 2 disappeared. It's now time to bring it back. The trick here is you divide both numbers in these brackets, or try to divide them both, by that 2 that disappeared. So, 3 over 2, see if it will simplify, get it to lowest terms. Once it is, and it won't divide, 3 divided by 2 doesn't divide exactly. If it won't divide, once being simplified, that is as simple as it goes. If there's still a number at the bottom, which there is, there's still that 2, we just shift that 2 next to the x instead. So this bracket here, we just rewrite as 2x plus 3. However, this one here, 8 divided by 2, we can do that. 8 divided by 2 is 4. If you can divide, do it, and replace it with that. So 8 divided by 2 is 4. So call that one x minus 4, and that's fully simplified now. That is the factorised version of this. And so we pop this here. We can now talk about the next step in terms of simplifying. So we've got 2x plus 3, x minus 4. Now hopefully you can spot on the top and the bottom is a factor of x minus 4. We can therefore cancel these off like so. And then we're just left with x plus 4 on top, on the bottom, 2x plus 3. And that's as simple as we can go. That is our final answer. Part B, we need to make v the subject of this formula. So I'll just write this out first of all. So we've got w equals 15 brackets t minus 2v all over v. We need to isolate, get one instance of v on its own on one side of the equation. That's what we need to aim for. So what we need to do here, first decision, we could multiply both sides by v to get rid of that denominator. So let's do this as our first step, multiply both sides by v. That will then give us wv, or vw. That denominator will have now vanished. We've now got 15 brackets t minus 2v. We can then expand this bracket here to get vw equals 15 times t is 15t. 15 times minus 2v is minus 30v. Now we want all of the v's to be together on one side of the equation. Right now I've got a v term here and a v term on the other side. So let's add 30v to both sides, and that will have the effect of making the v's vanish on the right and them all being together on the left. So if I add 30v onto the left, I'll now get vw plus that 30v equals 15t. I can now factorise out a v from this side. So then I'll get v brackets w plus 30 equals 15t. Then as a final step, we can now divide through on both sides by w plus 30. So therefore v equals 15t, all of which is divided by w plus 30. V is on its own, we've got it in the term v equals, therefore v is the subject, and we're done. Question 15, we have a triangle, and we're told its area is 6 root 2 square meters. We need to calculate the value of x, where x relates to the length of one of these sides. X isn't the length of one of these sides, but x is a variable in both this side and that side, and we know the angle trapped in between is 45 degrees. So we need to find x, given the answer correct to 3 significant figures. The factors given to three secant figures is a clue in itself that this isn't going to be anything that'll factorise or be a nice whole number. So this is going to be a calculated job for sure, but it's a calculator paper, so we're fine. The main thing to notice is this is not a right-angled triangle. Okay, it's not a right-angled triangle, and we therefore know it's not going to be a standard half base times height to find the area. If you know two sides and an angle in between, that relates to the area of a triangle by this formula, which you need to know. The area of any triangle is half times one side times the other times the sine of the angle trapped in between. So we can apply this formula here. So we know the area of a triangle is 6 root 2. So therefore, using this idea, 6 root 2 equals half times one side in between the angle, so let's call this one A. Let's call this one B down here, so that's 2x minus 1. And then sine of C, well, C is the angle in between, so that's going to be 45. One thing I'd suggest we do now would be to just multiply through by 2 to get rid of this half. So if I times everything by 2, just to get rid of this half bit, what we're going to get now is that 12 lots of root 2 equals x plus 3 brackets 2x minus 1. And then sine 45, well, if you know your exact values, you know what this is, or you can just use a calculator now to work out what sine 45 is exact value. Sine 45 is root 2 over 2. I can times that by root 2 over 2. Now what I can do is I can cancel both root 2 on the left-hand side and the right-hand side. I'll just section this off here like so to make sure I'm not going to run out of space like I tend to do. So I can divide through both sides by root 2 like so. And then afterwards, to get rid of this 2 here, I can then multiply both sides of it by 2. So after cancelling off root 2's, so the root 2's have disappeared, I have 12 here, so 12 times 2 gives 24. After cancelling off a root 2, that becomes half, but if I do half multiplied by 2, that just gives me 1 unit. So I'll just be left with x plus 3 brackets 2x minus 1 multiplied by 1, half times 2 is 1, but obviously times it by 1 stays as it is, so I've just got these brackets here, and that's all I need to consider. So this isn't a standard quadratic where it all equals 0. This one here is all factorised, so I need to expand back out and get it all equal to 0. So 24. So what we can do here, we can either use the grid method or FOIL, whichever you want to use. Just for speed, I'm going to just do it the quick way. I'm just going to talk you through what needs multiplying out. There's 4 things that need multiplying. So x times 2x gives 2x squared. And I need to do this first x times a minus 1 to give minus x. So multiply that x by everything on the second bracket, and I'll move on to the second term in the first bracket. Now I need to multiply this 3 by 2x. 3 times 2x is 6x. Then 3 times minus 1 gives minus 3. So we can now neaten this up, get everything onto one side. So I've got 2x squared minus an x, add a 6x. Overall, if I've got 6 x's and I'm taking away an x, I've got 5x left. I'm taking away 3. I can make this side equal to 0 by taking away 24. So if I take away 24, I get 0, which is what I want. But minus 3, take away another 24, takes me down to minus 27. Again, try that on a calculator if you want to be sure you're not going to make any errors in that. So normally, I'd say here, try and factorise this, but you could spend all day trying to find 2 numbers that multiply together to give minus 54 and add up to 5. So this is going to be one where we need to use a quadratic formula, and the quadratic formula is this thing here. So that's what we need to be using. X equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. So a is the coefficient of the x squared. For b is the coefficient of the x, which is our plus 5. And the c term is the constant number on its own, which for us is minus 27. So now all we need to do is translate this into the formula. So if I just move this up here, we can now calculate x by using the quadratic formula. So x equals minus b, so that's going to be minus 5, because our b is 5, plus or minus the square root of b squared, so 5 squared, minus 4, multiplied by a, which is 2 in our case, multiplied by c, which in our case is negative 27. Be careful with the negatives. And all of that is going to be divided by 2 lots of a, which is 2 lots of 2. So all we're doing here is just using the formula as you know it. And c was minus 27. So carefully just chuck these numbers into the calculator. So minus 5, we'll try the plus 1 first, so plus square root 5 squared minus 4 multiplied by 2 multiplied by negative 27, all of that divided by 2 times 2. So we get here this awful looking value, press SROD, we get 2.63. We want our answer to 3 significant figures, so x we've got as being 2.63. Let's just see what the other option gives us. So if I just toggle back, because it's plus or minus in this formula, you see. So what does the minus option give? Press minus, press equals. We get this here, which is minus 5.13. But if x were minus 5.13, then this one here, minus 5.13 plus 3, that'll still be negative. We can't have a negative length of the side of a square, so this one here, we can just completely reject this one. That's just not even worth considering. That is a nonsense. So the only solution we get, which makes sense, is that x must be 2.63 correct to 3 significant figures like required. Question 16, we've got an iteration formula to use. So I'm going to give you the long way of doing this, which hopefully will help understanding but take a little while. Secondly, I'm going to show you a very quick calculator-friendly way where you can do these questions in a matter of seconds. So first of all, bear with me, I'm going to try and get you to understand what's going on here. This formula is saying x subscript n plus 1 is minus 2 divided by 4 over xn squared. So compare n plus 1 to n. If n was 2, 2 plus 1 would be 3. If n were, say, 10, n plus 1 would be 11. This would be your 11th number, that would be the 10th. This is just saying your next number along in the sequence is based off the one before it. So x0 is minus 2.5. x1 will therefore be minus 2 over 4 divided by x0 squared. Okay, where x0 is minus 2.5. x2 will be minus 2 minus 4 divided by the previous value. 1 before 2 is x1 squared, and x3 is based off a previous value, x2. x3 is minus 2 minus 4 divided by the second value of x squared. So let's start off with what we have here for x1. So x1, we're told the value of x0 to pop in. If this is confusing you, bear with me, I'm going to show you a different method in a moment. So it's minus 4 divided by minus 2.5 squared. Now be really careful, because it's a negative, put it into brackets, and then square. So this one here is going to be, just move the calculator so you can see what's going on, minus 2 minus 4 brackets minus 2.5 in brackets all squared. That gives minus 66 over 25, which is minus 2.64. So that's what x1 is. So x1 is minus 2.64. That value we can now pop in to the formula for x subscript 2, which is based off this one. That's going to be minus 2 minus 4 all over minus 2.64 now in brackets, all squared. So now we just go back and we type in minus 2.64 instead into this formula. So it's minus 2 minus fraction button, 4, press brackets, minus 2.64, all of that now squared. That gives us this awkward number here. And because it's so awkward, I'm just going to leave it as that exact fraction. So minus 2803 all over, what was it? 1089. So that's what x2 is. And x2 is used to base off what x3 is. x3 is based off a previous one, which is x2. So this is going to be now the final one we need to work out, minus 2 minus, and then it's going to be 4 all over minus 2803 over 1089, all of that thing here squared. So let's calculate this. So minus 2 minus 4 lots. It's a pain, isn't it, having to remember what your previous answer was? Well, bear with me, I'll show you this trick afterwards. Minus 2803 over 1089, all of that squared. That gives minus 2.6037. I've got the numbers were now. 6037 67255. So these are our values. So the first one, x1, was minus 2.64. x2 was this number here, which we can work out now if you want to. Minus 2803. So as an exact fraction, it's this. As a decimal, if you want to, minus 2.57. Give a few more numbers. 392. 1028. Blah, blah, blah. Don't need to give all the numbers. That'll do. And the final one here, x3, was minus 2.603 767 255. So what's happening here is that the numbers are getting closer and closer together. So values are getting closer, and mentioned that in part B. Now I did say there's a quicker way of doing these questions. The key thing here, like I mentioned, is each next value is based off the one before it. One more than n is n plus 1, so you're basing it off an immediately previous value. The calculator you've got will almost definitely have an answer function on it, so I'm just going to mention how to do this even quicker. If I return to working out x1, so x1, we just base this off x0. So you need to know to do minus 2 minus 4 on top. Then you need to know to pop in x0 at the bottom. So minus 2.5 all squared, like so, equals this. But then this formula always stays looking exactly the same. Minus 2, then a minus 4 divided by the previous number squared. So what we can do here to work out the next value, x2, you can just simply go back here, because x goes in this place here, and x is always our previous value. We can just press delete and type in ANS to use our previous answer. So press equals, we get the next one. Then the beauty is, just press equals again, it'll give you the next iteration, the next cycle of the formula. So pressing equals again would have given you x3 immediately. So that's a quick way I want you to remember. This way I've shown you in red is just for understanding. The understanding will hopefully make it easier and makes it more understandable, but ultimately you can do these dead quick on a calculator. So now I'm just going to mention part B, which I think is a bit cruel. Part B is just testing if you've revised really hard, to be honest. Explain the relationship between the values of x1, x2 and x3 and the equation x cubed plus 2x squared plus 4 equals 0. This equation just seems to come out from nowhere. This isn't mentioned in part A at all. So I'll again try and let you understand where it's coming from. This first equation here, I could rearrange this so it looks like that. If I just call that an x and call xn, again just call that an x. If I multiplied through by x squared on both sides, I'd then get that x cubed equals minus 2x squared minus 4. That would then rearrange to this here. Okay, so it's saying what's the relationship between these values we've got and this equation. You need to just know with iterative formula, these answers, these values of x will converge. They'll zoom in on a particular value of x, which is the solution to any given equation where this iteration formula is derived from. You need to make a leap of faith and think, oh, this must be derived from that. Then remember, iteration always zones in on a particular answer for x and puts it in those words. So the best thing to write down would be that the values x1, x2 and x3 are increasingly accurate approximations to a solution of the equation x cubed plus 2x squared plus 4 equals 0. The idea of iteration is it will give you a really close answer. It will actually hone into the exact answer if you can't factorize or use a formula to get the answer using a different method. So that's question 16. The first thing we're told is that the time is 110 minutes correct to the nearest 5 minutes. So let's just think about the time. So it's been rounded to the nearest 5 minutes. So the best thing to do here is to think about what the smallest period of time could have been so that it was still rounded up to 110 minutes. So what's the smallest amount of time it could be? And the maximum. So what's the time minimum? And what's the time maximum? Well, nearest 5 minutes, just think about the 5 times table. Okay, so very quickly, 5 times table, 5, 10, 15, 20, 25, and so on and so on. You eventually get up to 100, then 105, then 110, 115, 120. And so it's been rounded to 110 minutes, so it must be closer to 110 than 105 or 115. So it's got to be within this zone here. So the defining boundary between it being closer to 105 or 110 is going to be 107.5. So that's going to be our minimum time, 107.5. The maximum time needs to be, so it's just before 110 compared to 115, so that's going to be 112.5. So we just put that over there, 112.5 minutes. So it's always going to end in 0.5 if you round it to the nearest 5 or the nearest decimal place or something. And the gap between that one and that one is always going to be 5 if you round to the nearest 5. If you round to the nearest 10, the gap between minimum and maximum bounds would be 10. So that's the time done. Now what we can think about is the next variable, which is the length of track. So the length of track is 270 kilometers long, and he's thinking it's been measured correct to the nearest 10 kilometers. So when we did the nearest 5 minutes, we were thinking of the 5 times table. Now we're doing to the nearest 10, we need to be thinking of a 10 times table. So imagine a 10 times table going up until you get to about 270. So you've got 250, say, 250, 260, 270, 280, 290. Then we can stop. Now it's been rounded to 270, which means that once it's been rounded, the actual exact length of the track must have been closer to 270 than to 260, and must have been closer to 270 than to 280. So go for exactly halfway between 260 and 270, which is 265. That tells us it must have been at least 265, so it would have rounded up to 270. So for the track, for the distance, it's been rounded to 270. D min, minimum distance must have been 265 kilometers. In the same way, the maximum distance is when it would have been at the boundary in between 270 and 280. Halfway between 270 and 280 is 275. So we've got the bounds for both time and for distance now. So now we can go ahead and just compute this. So what we're wanting to work out for part A is, could the average speed of this train have been greater than 160 kilometers per hour? So we want to find the maximum bound for the speed. So speed is going to be biggest when you're covering the furthest distance. So you want the distance to be maximum, and your speed is obviously quicker if you're covering that speed in a shorter amount of time rather than taking ages about it. So to compute the maximum speed, you go for the biggest distance and divide that by the shortest time possible. So maximum distance was 275, and the minimum time we established was 107.5 minutes. So that's what we type in. So it's going to be 275 divided by 107.5. So if we do that, 275 divided by 107.5. We get 2.558 and so on. But that is when we've divided by minutes. That's kilometers per minute. We don't want kilometers per minute, we want kilometers per hour. So to change from minutes to hours, because there's 60 minutes in every hour, we need to multiply this value by 60. So if we just do this on the calculator, whatever number we've just got, multiply that by 60, and you can see here we're going to get a value of 153.5 rounded to one decimal place. So 153.5 kilometers per hour. So they've done lots of hard work. Ultimately, you've not answered the question. The question here, which is being asked, is, could the average speed of a train been greater than 160 kilometers per hour? Well, we've just shown that it's actually 153.5 kilometers per hour. That's less than 160. So therefore, in conclusion, the answer is no. It mustn't have been less than 160, not more. So no, speed couldn't have been more than 160. Because even computing the maximum speed, the maximum possible is still under 160. So it might have been even less than that as well. So always answer the question, never assume you're done until you've actually answered what it's saying. It might be a yes or no. In this case it was a yes or no question. The final thing it's saying for part B is Jake's assumption is wrong. It was actually measured correct to the nearest 5 kilometers. So for part B, explain how this could affect your answer to part A. Well, if it were measured to the nearest 5 kilometers, then all that would be saying is that the maximum distance on the track would be 27.2.5, which would be even less distance. So then the maximum speed would have been actually even less, because the maximum distance would then be 272.5, not 275. So if the bounds were different, that would actually decrease the maximum distance, therefore decreasing the speed. So a bit of an awkwardly worded question just for 1 mark really, part B. But ultimately for part B, we need to say something like this. It won't affect our decision to part A. All it would mean is the maximum distance is 272.5, not 275. So therefore the maximum speed will be even less than what we worked out for part A. And that's all we need to put for question 17. Question 18, we've got a circle with 2 triangles sticking out from it and also a bit in it. Looks quite complicated. Let's just think it through. A, B and C are points on a circle, a radius 5, centre 0. So this centre is the origin of the circle. DA and DC are tangents to the circle. So let's start by adding these in. So from D to A and from D to C are tangents, which just basically means they're lines that are just scrape the outside of the circle. So I'm going to highlight these on in blue. So these are the tangents from A to D and from D to C. We're also told that from D to O is 9 centimeters. So this length in the dotted line is 9 centimeters. Let's label this on as well. We need to find the length of arc ABC. So that means the length of the circumference is the portion of the circumference as we go from A around to B and back to C. So it's just this red bit of the circumference. It's a fraction of the circumference, essentially. And what we need to remember as well is a circle theorem, that each tangent will always meet a circle at 90 degrees to the radius. And so this angle here is 90 degrees. This one here is 90 degrees as well. So that's worth adding in, like so. So now what we can do here, we can actually look at this triangle here at the top or at the bottom, just looking at this one here, and we could work out this angle theta if we wanted to, because we know that's 5 and that's 9, and we know it's a right angle triangle. So if it's a right angle triangle and we need to know more information, we should be thinking either Pythagoras or trigonometry. But because we're going to be interested in this angle here, why are we interested in the angle? Well, it's so that we can work out what angle we've got here for this red arc, then we can know what fraction of a circle we're talking about. So the angle at the centre is crucial. So this is trigonometry in right angle triangles, so we can use SOHCAHTOA. So just thinking of this triangle at the top and applying SOHCAHTOA to it, let's think if we can work out this angle theta. So what I'd suggest here, as ever with SOHCAHTOA, is to label the sides we know relative to the angle in question. So we're trying to find this angle I've labelled theta. Opposite to the angle is O. We don't know O, we don't actually care about the opposite side. The longest side is always the side opposite to the right angle. So opposite to the right angle is this 9 centimetre side. The longest side I'm going to label H for hypotenuse. The other side, if it's not the O or the H, it must be A. And so I know side A, which is 5. So let's highlight this in the SOHCAHTOA triangles. I also know the hypotenuse, which is 9. So I'm going to colour in the H for hypotenuse on the SOHCAHTOA triangles as well. So which triangle is most coloured in? Well, you can see here that the CA triangle is the most highlighted, therefore this is the one we pick. We're trying to find an angle, so we cover up C for cos. So because we're trying to find an angle as well, we don't just use normal cos, we're going to do cos minus 1. So theta is going to be cos minus 1 because we could up C. What's left is A on top of H. So it's going to be cos minus 1 of the adjacent divided by the hypotenuse. So that's cos minus 1. The adjacent is 5. The hypotenuse is 9. So cos minus 1 of 5/9. So the way we do this is shift cos, tap the fraction button, 5 on the top, 9 on the bottom, close brackets, press equals. We get 56.251 and so on and so on. So 56.251 degrees. Now, because this triangle and this bottom one are the same, this angle will also be 56.251 degrees. So what I can do here, I can just fill in that each of these is actually 56.251. So that's 56.251, as is this one. I can therefore work out the angle on the other side. I can work out therefore this angle here on the other side. Angles around a point add up to 360 degrees. And so this red angle will be 360, take away 56.251, take away 56.251 again. So that's my answer, 56.251. So the red angle on the other side of the circle will be 360, take away 56.251, then take away 56.251 again. So I can press my answer button twice, which means I'm going to take away 2 lots of my answer. So press equals. This angle here on the other side, therefore, is 247.497972. So this one here is 247, I'll just write it here actually, 247.497. It's so close to 0.5, I may as well just call it 0.498 actually. But I can leave that on my calculator screen anyway, so that I don't need to remember all these figures myself. So what I'm going to do here, I'm just going to pop this there like so, because that's the angle. Now, like I said earlier, the arc here is going to be a fraction of this circle. So therefore, we can finally say arc ABC is going to be a certain fraction of the circumference of a circle. The circumference of any circle is pi multiplied by the diameter. If the radius is 5, the diameter is always double the radius, the diameter is going to be 10. So what fraction of a circle do we have on this side? Well, in a full circle, the total degrees at the centre is 360. So out of a total of 360, on the side where we want to calculate the arc, we have an angle at the centre of 247.498. Essentially the answer we've got stored on our calculator currently. So arc ABC is that fraction out of 360 multiplied by pi multiplied by the circle's diameter. So this awkward 247 point number I've got stored on my calculator now. So that answer I've got over 360 multiplied by pi multiplied by 10, that's the length of arc ABC. So it's 21.6, correct to 3 significant figures. 21.6 centimetres, and then we're done. Quite a tricky question, that one. That's question 18 for you. Question 19, we have to solve 2x squared plus 3x minus 2 greater than 0. So a quadratic inequality. Well, what I'm going to suggest we do first of all is think of this as 2x squared plus 3x minus 2 being equal to 0. We'll deal with this inequality after. So let's just think of it like this for now. So the first thing I'd always say is, does this factorise? If it doesn't, and it's a calculator paper, we can always use the quadratic formula. Okay, but as it so happens, this one will factorise. If we slide that 2 to the minus 2 and multiply, we can now think of this equation, if you like. We'll come back to the inequality in a moment. There's x squared plus 3x. Then take this 2, times it by minus 2 to give minus 4, and think of that as being equals 0. Now we need to think of two numbers that multiply to give minus 4 and add up to positive 3. With a bit of thinking, you should find those numbers are positive 4 and minus 1. That 2, though, we made disappear, and we just times it by the minus 2. This 2 needs to come back. The trick here is now we divide both numbers in these brackets by this 2. So if we can divide the number by 2, we just do it. 4, can we divide it by 2? We can. So x plus 4 over 2, we just write as x plus 2. The next one, minus 1, can we divide that by 2 with no remainder? No, it's going to always be a fraction. Will this fraction simplify? Not any further. So if it won't simplify any further, and 2 won't divide into what's above it, you just shove the 2, or whatever number is down here, next to the x. So that just gets rewritten as 2x minus 1 equals 0. So for one bracket multiplied by another to be equal to 0, we know for definite one of these brackets must have a value of precisely 0, because any number multiplied by 0 gives 0, which is what we want. So if this bracket's equal to 0, then x would have to be equal to minus 2, or for this bracket to be equal to 0, x would need to be equal to a half. Now, what I'm going to suggest we do is we think about plotting this as a curve. So let's imagine 2x squared plus 3x minus 2 as a curve. We can now start thinking about this as an inequality rather than an equation, which I've done here. So let's plot this or sketch it on a coordinate grid. So the coefficient of x squared is positive. It's a positive 2x squared, so it's going to be a happy parabola. It's going to be a U-shaped graph, and it's going to cross the x-axis. It's going to be equal to 0 when x is equal to minus 2, so I can put here minus 2 there. It'll also cross at a half, so I just put a half in here. And this curve, like I said, it's going to be U-shaped. It's going to go through these 2 points. So it's going to be something looking a bit like this. But we want this curve to be greater than 0. We're wanting it to be more than 0. So this means, in terms of whereabouts we want it, we want this curve to be above the x-axis. Above the x-axis is where it's positive, below is where it's negative, where it's less than 0. But because we want it to be greater than 0, we want where this curve is above the x-axis. So you can see here there's 2 bits of it which are sticking out above the x-axis. One bit is this region here, and the other bit is this curved bit on this side as well. So it's clearly more than 0 when x is to the smaller side of minus 2. So it's going to be bigger than 0 when x is less than minus 2. And the curve is above the x-axis on the bigger side of x to a half. So it's more than 0. It's higher than the x-axis when x is greater than a half. And these here are our solutions. So because we want it greater than 0, using this graph as a helper, we therefore know that either x is less than negative 2 or where x is greater than 0.5 or as a fraction a half. And that's the solution therefore for question 19. Finally, we arrive at the final question, question 20. So we're told the equation of a curve is y equals a to the power x. A is a point where the curve intersects the y-axis, state the coordinates of A. So one way we could do this would be to imagine this graph of y equals a to the x. So the actual graph of y equals a to the x is like this. It's a curve which goes up at an ever increasing rate. As x gets bigger, y gets absolutely huge. As x goes very, very small, y approaches but never quite gets to 0. So this is what the graph looks like. Ultimately though as well, we need to think about where it crosses the y-axis. So what is the value of x where any curve for that matter crosses the y-axis? Well, at the y-axis, x is neither positive, it's not over here, nor is it negative, x isn't over here. On the y-axis, x is exactly 0, and that's the key point. So where we cross the y-axis is always where x is 0. X equals 0 wherever you cross the y-axis. So based off this, we can just sub in what y is when x is 0. So when x is 0, y is a to the x, which is a to the 0. Now anything to the power 0 is 1. So therefore, where it crosses the y-axis, which is this point here, that's when x is 0 and y is 1. So therefore, it crosses the y-axis. The coordinates of A is here. A is just simply 0, 1. So that's part A. For part B, we're talking about a circle. So the equation of a circle, C, is x squared plus y squared equals 16. So if this is the equation of a circle, we need to know the equation of any circle for GCSE is x squared plus y squared equals the radius squared. So 16 is the radius squared. So the radius is the square root of 16, which is 4. And this will always be a circle centered on the origin, 0, 0. So if we imagine this circle being drawn on a coordinate grid now, so here it is. So if it's centered at 0, 0, and the radius is the square root of 16, which is 4, then where it crosses the x-axis will be 4 and minus 4, and equally for the y-axis, up here will be at 4, down here will be at minus 4. So we can add these on as well. However, so this isn't actually the question. The question is, where does circle C end up if it's translated by the vector 3, 0 to give circle B? So the blue one right now is circle C. We need to think about where circle B would end up. Now, it's been translated by this vector here. The top number means how far it moves to the right. The bottom number tells us how far it moves up. So here it just moves 3 to the right, doesn't move up or down. So we need to move circle C 3 units to the right in order to get circle B. So we take this circle at C, and then we're going to move it 3 units to the right. And so circle B will be circle C shifted 3 units to the right. So if I just colour code this in red, so we're going to start here, then we're going to move 1, 2, 3 to the right like so. So if we move 3 to the right, then we need to think about this x-axis intercept. 3 to the right means minus 4 plus 3. This point now will now be minus 1. This point here, 4, has now been moved 3 units that way. So this x-intercept is now 7. So label with coordinates the centre of the circle B and any points of intersection of the x-axis. So this here is minus 1, 0 if you like. This one here is 7, 0. And the centre of the circle used to be 0, 0. If it's been moved 3 to the right, the centre of the circle is now going to be 3, 0. And so the centre of the circle is 3, 0. And the points of intersection with the coordinate axis, the x-axis, are minus 1, 0 and 7, 0. And that's all we need to do for question 20, which is the last question. Therefore, we've done the whole paper. Thank you for joining me, and I hope you found it useful for some questions, if not all. Hopefully all of them, of course. Do feel free to like, subscribe and leave comments, and stay tuned for the next video, which will be coming as soon as I can get round to it. So once again, a sincere thank you, and take care of yourselves until next time. From me, goodbye from now.